What if the future of artificial intelligence isn't on Earth anymore? Not in Silicon Valley, not inside giant warehouses in Texas, not buried under the deserts of Nevada, but floating silently above us, in orbit. Thousands of AI supercomputers circling Earth at nearly 28,000 kilometers per hour, powered by endless sunlight, thinking, calculating, and processing the internet from space itself. It sounds like science fiction, but here's the strange part. Some of the world's biggest tech and aerospace companies are already exploring the idea. And if AI keeps growing at the current pace, Earth may not be able to handle it for much longer. Because the next problem humanity faces might not be building smarter AI. It might be figuring out where to put it. Right now, the AI boom is consuming infrastructure at a terrifying speed. Every chatbot response, every AI-generated image, every deepfake video, every recommendation algorithm, all of it runs through data centers. Massive facilities filled with rows upon rows of servers and GPUs. And these aren't normal computers. Modern AI systems rely on extremely powerful chips made by companies like NVIDIA. Some AI training clusters contain tens of thousands of GPUs running simultaneously. Imagine an entire city, except instead of houses and roads, it's processors, fans, cooling systems, and endless electricity consumption. Training a single advanced AI model can require enormous amounts of power, and this demand is exploding. Because AI isn't slowing down, it's accelerating. Faster models, bigger models, real-time video generation, autonomous systems, AI assistants everywhere. The future internet may be powered almost entirely by machine intelligence. But there's a problem nobody talks about enough. Earth's infrastructure was never designed for this. Modern data centers already consume massive amounts of electricity. Some facilities use as much energy as small towns. And power isn't the only issue. Heat is becoming a serious problem. AI servers generate unbelievable amounts of thermal energy. That's why data centers require giant cooling systems operating 24/7. Some even consume millions of gallons of water every year just to keep servers from overheating. Now multiply that problem by the future of AI. Millions more GPUs, constant real-time processing, entire industries automated by machine learning. Eventually, we hit physical limits. Cities don't want giant, power-hungry server farms nearby. Electric grids become overloaded. Cooling becomes more difficult. Land becomes expensive. And the environmental cost keeps rising. So engineers started asking a strange question. What if the best place for AI is somewhere Earth isn't? Space changes the equation completely. In orbit, there's no land cost, no real estate problem, no local power grid limitations, and most importantly, there's sunlight. Almost constant sunlight. A satellite in the right orbit can receive solar energy for extremely long periods of time without interruption. That means a space-based AI system could theoretically generate massive amounts of electricity using solar panels alone. No coal plants, no giant cooling towers, no urban power shortages, just sunlight. And then there's cooling. Ironically, one of the biggest problems on Earth becomes easier in space. In orbit, there's no atmosphere trapping heat like on Earth. The environment of space creates entirely new possibilities for thermal management, which means future orbital servers could potentially cool themselves far more efficiently than traditional Earth-based facilities. Suddenly, the idea starts sounding less insane and more inevitable. Forget giant buildings. The future space data center probably wouldn't look like a building at all. Instead, imagine a swarm of modular satellites, each one carrying advanced processors and AI chips. Thousands of small orbital computing nodes connected together like a giant floating neural network. A cloud server farm spread across space itself. These satellites could communicate using laser links instead of traditional radio. Extremely fast, extremely efficient, almost instant. Data could bounce between orbital systems at the speed of light. Some concepts even imagine autonomous robotic maintenance systems repairing damaged satellites in orbit. Entire machine ecosystems maintaining themselves above Earth. And of course, they'd still connect back to Earth through ground stations and satellite internet systems like Starlink. In theory, you could access a space-based AI server from your phone without even realizing the computation happened hundreds of kilometers above your head. AI is different from traditional computing. Normal internet traffic is relatively manageable, streaming videos, loading websites, sending messages, but AI requires enormous parallel computation, and future AI systems may become dramatically larger than anything we have today. Imagine real-time planetary simulations, fully AI-generated movies, instant language translation for billions of people, massive scientific discovery engines, global autonomous robotics networks, all operating simultaneously. Some researchers believe future AI systems may require computational scales so large, Earth alone becomes inefficient. At that point, orbital computing stops being a luxury. It becomes infrastructure, like railroads, like highways, like power plants. Human civilization expands its computing power into orbit because it has no other choice. And once that happens, space stops being space. It becomes part of everyday industry. But there's one issue. Space is brutal. Absolutely brutal. Radiation in orbit can destroy electronics over time. A tiny software error could disable an entire satellite. Micrometeorites traveling faster than bullets could puncture systems instantly. And repairs? That's where things get complicated. If a server fails on Earth, a technician walks into the room and swaps hardware. If a server fails in orbit, you may need a rocket launch worth millions of dollars. And then there's latency. Even though satellites move data quickly, physics still matters. Some applications require ultra-low latency that may still work better on Earth. Then there's space debris. Thousands of satellites already orbit Earth today. Adding giant AI computing clusters increases collision risks dramatically. One catastrophic chain reaction of collisions, sometimes called the Kessler syndrome, could make certain orbits dangerously crowded, meaning humanity would need entirely new laws, traffic systems, and orbital regulations just to manage future computing infrastructure. We wouldn't just be building data centers. We'd be building an economy in orbit. Here's the craziest part. The first steps are already happening. Space agencies and private companies have been experimenting with orbital computing systems for years. Even NASA has tested edge computing technology aboard spacecraft and orbital missions. Modern satellites already process data in space before sending information back to Earth, which means computation in orbit is no longer theoretical. It already exists, just on a smaller scale, and launch costs are dropping fast. Reusable rockets from companies like SpaceX are making space dramatically more accessible than it was a decade ago. At the same time, AI demand keeps climbing. Those two trends are moving toward each other rapidly. Cheaper access to orbit and an endless need for more computing power. That intersection could reshape the future of the internet itself. But maybe this isn't only about AI. Maybe this is the beginning of something much bigger. For decades, humanity treated space as exploration. Flags, missions, science experiments. But now, space is becoming infrastructure, communication, navigation, surveillance, manufacturing, and possibly soon, computation. The internet once spread across the planet. The next version of it may spread beyond the planet. A civilization connected not just by cables underground, but by intelligence orbiting above the atmosphere. And maybe one day, future generations will look back at Earth-based data centers the same way we look at old steam engines. Primitive, heavy, bound to the ground. So the real question isn't whether AI data centers can exist in space. It's whether humanity eventually has any other option. Because the moment our intelligence outgrows the planet, we won't stop building. We'll keep expanding, upward, into orbit. And maybe one day, the most powerful mind humanity ever creates won't live on Earth at all. If this future becomes reality, who controls it first? Governments? Tech companies? Or AI itself? And what comes after orbital computing? Moon servers? Mars internet? Entire AI civilizations beyond Earth? Subscribe for more future tech stories. And comment below. Would you trust an AI data center floating above your head?